Eddie again. I forgot to mention before, but yeah, so I've been doing FLL for, don't remember, I think 5 years or so, and then I moved up eventually to FTC and FRC, and now I am currently sophomore in college. But yeah, so now I'm just going to spend a little bit of time talking about programming and basically just some tips and tricks, some logistics information stuff about programming this year, since it's a little bit weird this year compared to other years, since there's a bunch of stuff changing and a bunch of stuff is kind of in flux. Yeah, just tons of weird stuff this year. This year, so let's take a look. So for the past 7 years, this has kind of been like the way you program your EV3. So this is called, or I'm going to call it EV3G software. Since it's just like EV3 graphical software. And yeah, so this ran fine for the last 7 years. But then about last year, we had this little pop-up start appearing on Macs, or with the latest version of macOS. And basically, this means that this old 7-year software is no longer can be used on the latest version of macOS. Okay, so Lego went around and they made this weird, or not weird, it's like Scratch based. And then so then they introduced this Python thing. Then they came around and introduced a completely new robotics development platform. This is very, very confusing. And so today we're going to kind of go through some of these different options and try to demystify this a little bit for you guys. And then once we do that, we're going to get into some more strategy and just like some basic tips for what judges are expecting maybe this semester or this season, since it's such a weird season. But yeah, so let's get into first just a brief aside from the FLL rulebook. On rule R02, it says that you can use any software that allows the robot to move autonomously. And what this means is this is kind of interesting because in previous years, I'm not sure about last year, but definitely year before last year, they were restricting you to only use the software, the official EV3 software. That was like the official old EV3G software that you could use. But this year, you're actually free to use anything you want. And that gives you a lot more control, and it can certainly make it a lot more confusing. So hopefully this will help a little bit. So let's start out with EV3. So kind of just like state of the union stuff. Right now, EV3, there's kind of two main ways for you to program your EV3. So the first one is the old EV3G software. And it used to be the only choice. So it used to run on both Mac and Windows, and it would be, it would get the job done. But as of last year, this old software actually does not run on the newest version of macOS anymore. And this caused Lego actually to kind of make this new Scratch-based software on the right. And the reason I say kind of make is because this is actually based, if any of you have seen the new kit, or the new robot kit called Spike Prime, this is kind of based on the same type of software. And this currently only runs on macOS. So it's kind of weird because right now we have one software that only runs on Windows, and then one other software that only runs on macOS. However, Lego does claim that they're working on a Windows version for September. So hopefully that will be out before the season starts. But as of right now, as of today, we have two different softwares for two different operating systems. I'm quite hopeful that they will be releasing the Windows version this September, but they actually claimed that they were going to do it in the spring, and they didn't, and they pushed it off to September. But now that it's almost September and they haven't pushed it off again, I'm really hoping that they can get this in. But yeah, before we move on, let me just show you a quick demo of these two different types of software. So you can see here, this is the old EV3 software. This is actually a line following program that I just wanted to put here to show you guys maybe some of the differences between the software. So this is, for any returning teams, this will look very familiar. And you basically just have these blocks that you drag around. And if you have, this is a loop block that will loop things around. And then you have motor blocks. There's even if statements and stuff. But, it's kind of weird. If you want to pass data around, like if you want to read sensors or anything, you have to use these little wire thingies that might not be very intuitive. And there's also no real words or anything. And it can kind of look a little bit intimidating. So the new type of software actually looks like this over here, which is Scratch-based, if any of you have used Scratch before. And it basically has kind of the same types of blocks, or the same, most of the blocks are very similar from EV3 and from old EV3 to new EV3. but it's just kind of the way you put them together is a bit different. And actually, I quite prefer this method a little bit, since you can see this is actually the same exact program on the bottom and the top here, but the one on the bottom is quite a bit shorter. And I think it's actually a little bit more readable since there are words, and yeah, hopefully this is a bit more approachable for newer teams as well. But yeah, now that we've seen that, you might be asking yourself, like, which one should I use? What happens if my team is both Mac and Windows? Or what happens if, I'm not sure which one I want to stick with? Well, let's take a look at a brief overview of kind of software for beginner teams. First option is if your teams are all Windows or all Mac, then the option is much easier because you can just use the software for that computer. Or if you're all of your programmers, if you're just using one main computer to program, you can also just use the software that works on that computer. Although that might not be as applicable nowadays, because since we have coronavirus, you're probably going to have multiple programmers or multiple computers that are going to be using the software that are kind of spread out over space. So yeah, so if we're using both Windows and Mac, you're going to have a few different options. So the first option is if your Macs are not running the latest version, you can use the old EV3 software. So if your Mac is running the version from, I think, 2 years ago, anything before Catalina, if you know what that is, you can still use the old software. Otherwise, another really janky option is you can always try running a virtual machine or something to run Windows on your Mac. But I really would not suggest this, especially for beginner teams, even for more advanced teams. This is just kind of a major hassle that you shouldn't have to deal with. So I think my recommendation is that you should be looking at moving to the Scratch-based software this year. And hopefully LEGO will release the Windows version in September, so you can be using the same software on both your Windows machines and your Mac machines. And the reason I say that you should be moving to the Scratch-based software is, well, first, it's easier to explain, easier to read than the old EV3 software. But it's also just, it seems like Scratch is a direction that LEGO wants to move in the future, especially with their new kits like Spike Prime. And then later on this year, they're going to be releasing, I believe it's a Robot Inventor or something. But one thing to make sure not to do is to don't split your team across using these two different types of software, because that's really just going to hurt collaboration. It's going to be quite confusing. And if you want to integrate these programs with each other, or if you want to combine two different missions or something, it's going to be really, really difficult to be able to merge these two things together. So stick with one type of software. Hopefully, just keep an eye out for the Windows version, and hopefully that will hopefully come soon, and then we can get everything on the same page, and everything will not be confusing anymore. So that's basically my suggestions for beginner teams for EV3. Moving on, for more advanced teams, there's actually one more interesting option. I wouldn't really recommend it, but you should be aware of it, which is MicroPython, or specifically Python that runs in EV3. And this is actually quite new. LEGO actually just released this, not sure, probably around last year, but basically they're now officially supporting Python on EV3. So now that the programming restrictions are lifted, Python is definitely an option for you for advanced teams on EV3. So yeah, so if you're an advanced team, suggestions that I just gave for the beginner team are still valid, but Python is definitely an option you should be aware of. And kind of the main advantage of this option right now is that it's working on both Mac and Windows at this current point in time. So if you just want stability, this might be a good option for you. It's also a little bit more powerful since it's text-based. It's definitely, you can probably code it a little bit faster if you know how to use it. And it might also be more impressive to judges. But that's only the case if your team members can really clearly understand, clearly explain this. It should definitely not be driven by you. So let me show you a little bit actually what this kind of looks like. So you actually use this type of, or LEGO recommends using this editor called VS Code, if any of you are programmers out there. But basically, it's just normal Python. This is actually, I'm using the same program basically for all of these examples. So you can see, this is the line following program in Scratch. Here we have our line following program in Python. And so we have a bunch of here we just get our drive base ready, our motors ready, and then here is our main loop over here. But you might also notice it's kind of long, and it's I think this is actually harder to read than the Scratch by far. And there's also some really, really weird inconsistencies with Python here. Like you have to, um, all these things are in millimeters per second or in degrees per second, but on Scratch they're in percent and they're in like 0% to 100%. Here it's 0 millimeters a second to whatever, I don't know. And then there's also tons of little weird things you have to do. Like you have to make these like this whole drive based thing is not something I really like, and I think that this will be very confusing for your team as well. So I really really would not suggest Python for EV3 specifically, unless the coach, you know what you're doing, you know how to code, and you're really really willing to be very hands on with the way that this is being used in your team. But my main suggestion, even for advanced teams or for beginner teams, is just stick with Scratch and you know start learning Scratch and get that into your actual development workflow. And also another reason why you should why Python's kind of probably not a good option for EV3 is you actually have to run a different OS on your physical EV3 brick to use this. So you have to just tons of moving parts. Probably not recommended. So for now, just main team or the main suggestion for me is just use a Scratch-based software and wait for LEGO to release the Windows version. And then that's all for EV3, but just really quickly for Spike Prime, if any teams are using this, it's much more straightforward for Spike Prime. You have one single tool, which is this Scratch-based environment. It works on Mac, Windows, Chromebook, iOS, Android, everything's out right now. And it's really, really nice because you actually get every single feature that you can get on your computer on a tablet. So if you have some people using iPads, you have the full development experience on your tablet. Where on EV3 right now, you just have a very, very kind of like a cut down experience on the iPad. And I wouldn't suggest using your iPad to code for EV3 until maybe later this year when they update it. But since this is kind of when Spike Prime was released, they use this editor first, so it's much better supported than EV3 Scratch actually. And I actually think it's, even though it's very very similar to EV3 Scratch, I think it's actually a little bit more intuitive, or it's a bit more polished, and that's definitely nice. So if you're a beginner team, just use this. This is not there's really no option for you. This is clearly, I think, the best option. And you can see I actually have both editors up here. Oops, this one is the same program as this. Looks very, very similar, just a few minor wording differences. And you can see that you can basically do the same thing on Spike and on EV3. And it's quite nice. You have your movement, your light, all these different blocks are very, very similar to Scratch or very similar to EV3. So, all right. And then one other thing, though, is that for more advanced teams, too, for Spike Prime, Spike Prime also supports Python. And but it's a lot less janky, and it's a lot better supported than EV3 Python, because basically right inside the app, even on tablets, you get this other mode, which is called Python mode. And you can choose between these two modes when you're creating a new project. It actually asks you, do you want to make it with word blocks or do you want to make it with Python? And this is actually the same program as this old Python thing that I showed you, but it's much, much shorter. And I think it's much easier to read. And you also have this nice documentation all the way on the right side on the screen. So it's a lot closer to Scratch programming, I think, than this, because everything is still in percents, everything is still in centimeters here, and then you have much easier ways of creating like pairs of motors, or in making distance sensors or color sensors and stuff. So I think that Python for Spike is actually a real option, and so it's much less confusing than EV3 Python. And while I wouldn't suggest that beginner teams or advanced teams actually use this as like their full programming thing, I definitely think that this might be good for maybe some beginner teams to just poke around with a little bit and just to see what's out there, just so you can kind of be familiar with, you can show your team like, oh, this is your Scratch programming, but if you wanted to, this is actually kind of what program I shift to in the future when you get into some more text-based code. And it's a nice transition, since they're kind of very similar building blocks in both types of programming environments. So yeah, so just some takeaways. LEGO is moving to Scratch. So you should be looking to transition to Scratch. And the learning curve is actually quite small, I think. For old teams, like the blocks are basically the same. For new teams, it's pretty easy to get started. Since Scratch is pretty new for EV3, there's definitely less resources right now, but hopefully this will change in the future when people start moving more and more to Scratch. If you're kind of wondering about Spike Prime versus EV3, that's a whole other topic. For now, just stick with what you have. And if you have any more questions, just ask questions in Q&A. Actually, personally, I quite like the Spike Prime, but it's a little bit, as Michael was saying earlier, since you only have 6 ports, it can be a little bit restrictive. And before we move on, I guess there's a few questions that people had. Yeah, so EV3 MicroPython is supported by Lego. It's actually based on an open source project, but it's fully endorsed by Lego. Lego provides the libraries. Lego provides the development tools, or at least most of them. But yeah, I still wouldn't recommend it because since Lego kind of just borrowed the code from someone else, it's not really made from the ground up to be the same as other Lego products. So it's quite a high learning curve to use that. Alan was asking if there's 2 Spike versions. There's actually just one. The reason I have these 2 different things pulled up is because the Spike programming app and the EV3 programming app are actually different, but they're based on the same kind of ideas or the same type of coding. But yeah, so Spike, there's just one Spike Prime. Actually, eventually, Lego is planning on releasing a new robot kit that's actually the same as Spike Prime. That's a whole other story. So if you have any questions, let us know in the Q&A. But this is basically just what you need to be aware of right now. Different hardware. I think, as far as I'm aware, there is currently just one Spike Prime hardware. And of course, you can buy extra sensors and stuff. But that's it's pretty standardized right now. So now that we have that out of the way, we can actually get into talking a bit about programming strategy. So just in general, disregarding any types of different programming software, we have a few different tips and tricks you can try to use when you're programming your robot. So, I think you saw this a little bit in the teams that that presented the robot design. But, well, first of all, you should be using these things called MyBlocks. Or if you're a more advanced team, this is definitely something to look into, because MyBlocks are kind of like if you have some code that you want to use over and over and over, the judges will be more happy if you use MyBlocks instead of copying and pasting this code over and over. And basically, MyBlocks are a way to, like over here on Scratch, if I make a new MyBlock, I can just here I can just, make some code that I can put in the MyBlock. And then every time I use this MyBlock in my code, it'll run the code that I just, it's basically like making a function, if you know what a function is. But it's a nice way that you can reuse code. I would suggest looking it up, since there's only so much I can cover in this session, but it's definitely something you should be aware of that exists. And then the second major thing that I wanted to talk about is just when you're programming, you should really, really be aware that the motors that you're using are very imprecise, or you should not trust the motors to get you where you want to go every time. And there are a few ways to kind of mitigate this, or you should really be using sensors, or also using just physical pieces on the field to orient yourself. And what I mean by this is that, there's 4 walls. The walls are always in the same place, or always in almost the same place on the field. Then there's also a bunch of mission elements. There's all the things on the field that are stuck to the field, and those are also always in the same place. So the first suggestion that I have is you can try to use some of those to orient your robot when it's moving around. So if you're moving along a wall, you might want to use some sort of rollers, or it's kind of like put a mini wheel on the side of your robot, and then you can kind of follow the wall. And then if you're following the wall, you're exactly on that wall, so you have no you have no chance of inaccuracy in terms of your X position on the field. And then another option is wall squaring, where if you want to make sure that you're turned to the right angle, and you can back up into the wall, and or back forward into the wall, and you can just kind of square up against the wall, so you're exactly 90 degrees to the wall, and that gives you wall falling will give you an exact position. Wall squaring can give you an exact angle, and then that can be very, very helpful to kind of just reorient yourself in the middle of your missions. This is more for advanced teams, I think, than beginner teams, because for beginner teams, if you're only doing one mission at a time, this is much less critical. But for advanced teams, you should be looking to constantly reorient yourself on the field. Then in terms of sensors, you can always like look at the colors on the mat. That can be a little bit finicky sometimes, so I would use it sparingly. But you can always just try to figure out where you are by the color on the field. And then also with your color sensor, there's a bunch of lines on the field usually, and you can use these lines to follow these lines and just know exactly where you are. The code I showed you here is actually kind of a line following program. And using something like this, you can follow the lines in your field. I'm not going to go into it since we have very limited time, but all of these things are something you should search up and look at. As a coach, you should look at tutorials for this, try to play around with it a bit, and then you can try to let your team members definitely figure it out themselves. But you should definitely be aware of these things as your team is planning or as your team is strategizing for the season. And then finally, if you want to make more precise turns too, there's something called a gyro, which is basically just like it can tell you your angle relative to the field. So if you stick it on your robot, you can make much more precise turns with this gyro. So yeah, I'm just scratching the surface here with stuff that you can do. But if you just want to search this up later, you can definitely get much more detailed explanations. I just want to make sure that you guys are aware of all these different things that you can do with your programming or with your robot. Yeah, so one last slide. I just want to kind of go over a few different goals that you should be keeping in mind this year when you're programming, since obviously this year is a little bit different from other years. So, this year, since you're going to be mostly remote and then your competitions are going to be really weird, there's less emphasis on the results. And with your programming, you should really be looking to nail down your progress and your process this year. So really what judges are looking for is they're looking for how your team works together, even when there is difficult time, and also how much progress you made. So as a coach, you should really encourage first code understanding. So your team members should really be able to easily explain code to judges. So if you have some really complicated line following script or some complicated things that you do to align yourself, your team members should really easily be able to explain this to the judges. And this is, I think, very easy with Scratch. Sometimes with Python, it can be harder. So you should really be able to weigh this when you're trying to decide what you want to use. And then beyond that, this year also really has a large emphasis on collaboration and also just iteration. So you should be testing, improving, documenting, repeating, and then doing this over and over and over, so that eventually you have actual evidence of your program being, this is where we started, this is what we noticed, this is how we improved it, and then this is where we are now. And this is also kind of tying into some other things that that I think the robotics team was sharing from earlier, how they're using like an agile model of development. You should kind of do something similar where you're testing constantly, improving your code, and you have evidence of this for the judges to see. And then finally, just brief side on how to collaborate remotely. I think if you're comfortable with it, you can have some like mini team meetings for programming in person. Obviously, this might not be an option for some people. But then you can always obviously screen share over Zoom. You might have one person doing coding, some other people suggesting. And then I would kind of, in general, just as a general approach thing, I would recommend just as a coach, just making sure each programmer has like some clear idea of what to do, since it can be very difficult to communicate remotely. And then also just try to do code reviews, or at least have people look at other people's code and then send code around for other programmers to look at. And then one other tool that I've heard some people use is this thing called the Virtual Robotics Toolkit, which is basically it's like a simulation environment where you can build your robot using the software I think Michael was talking about earlier, Studio 2.0, and then you can import it into this environment and then write code for it virtually and then upload it into this virtual robot and test it out. It sounds cooler. It sounds cool. It is pretty cool when you use it. But the unfortunate thing with Virtual Robotics Toolkit is it only supports the old EV3 software. So this might not be an option for people in the future unless they update it. But yeah, that's pretty much programming. If you have any other questions, we can always